Welcome to part 6 of the JSL Decoded video series. In the previous video we created a column dialog which allows us to select a Y response and a list of predictors. And we have been developing a script that currently looks like this. It allows us to select a single predictor and then produces some output. So the goal for today is to update this script so that this dialog gets replaced with a new dialog that we have produced. So let me just prepare these scripts. We need this script which I've called lesson 4. This is the script that's going to be modified. This is the script we've been developing over the last few videos, and the script from the previous video is this column dialog. So my goal is to insert the code on the left hand side into the code on the right hand side, and I just need to do that in a way that everything continues to work. So let me first of all focus on this. This reference here is really talking about namespaces, and we always, well personally I always like to deal with namespaces at the very beginning of my script, and this additional script that I have here has got reference to namespaces. So I want to put this piece of code onto the right hand side. Now for me to easily keep track of what I'm moving, I'm actually going to cut this, but I'm going to make sure I don't save this script, but I'm going to cut it and paste it here. So that's all part of namespace definition. And now I have a new window for the column selection, so let me focus on where that is done. If I come down, I have a section for the main code, and as part of that main code I have a window for doing the column selection. But before there I do some validation, and I probably want to keep some of the validation. So let's work at this line by line. So I have a Y column name which has been hard coded to Oxy, whereas in the script on the left I create a list of Y's. Now the first item of that list is going to be the Y column name, so why don't I take this and remove it and put it down here, and I can say Y column name is going to be list Y1, so the first item in that list, and maybe just put a space there. Okay, back to here I have some validation, so I'm happy to keep that validation. This is just validating that I have a data table open. But then we have logic to deal with building a list of columns which then goes into this window, and all of that logic I don't need, so I'm going to remove from the list all the way down to here. So I'm now just left with the validation of the data table and the assignment of the X column name, which is the most fundamental logic that we're doing. Now that X column name, again, I can just cut and I'm going to paste on the left hand side, and that's going to be the first item of list X. So now I can take everything, I think, from the left hand side. I don't need names default to here because I already have something similar on my main script, but I can take everything else and just select all of that, and I'm going to paste that between this validation of the data table and the new window, which is the main output of this script. So that's pasted in. I no longer need this show statement, but that should all work, and I'm finished with the script on the left hand side. Let's test that it does work. So I run the script and I'm getting the dialog. If I assign the columns, then I get the correct output. Okay, excellent. The next thing that I want to do, and the reason the dialog asks for a list of X's, is I want to attach to the graph builder a column switcher. So if I just set this up, so I'm going to swap runtime with a list of X's. So that's the output that I want to have. So I want to use the list of X's to create this column switcher. So how do we do that in code? Well, Jumper is going to give us the clue So if I save this script to the script window, there's my code to create Graph Builder with a column switcher included. Now let me look at where this is done inside the existing code. So we have some function definitions, and I have a function definition for my graph, and here I have the Graph Builder. So within here I want to attach the column switcher. For reasons that hopefully will become apparent, I don't want to embed the column switcher definition within the Graph Builder specification itself. So there's a second way we can do the same thing. I can take Graph Builder, a reference to Graph Builder, if I say GB equals this, and then once I've created that vlist box, I'm going to take GB and I'm going to send a message to it, and the message is this column switcher. So instead of embedding the column switcher, it can be presented as a message to Graph Builder. Now what do we have inside this? We have a column specification, and that's the X column. So I'm going to replace runtime with xcol. And then I have a list of columns, and that list is the equivalent of what we have called list X. So I'm just going to specify list X here. Now this is a message. I don't need to mess around with things like evals because we're not inside a platform now. So the X column should be fine. List X though is not defined. We have list X within our script but not within our function. So all the variables inside the function are local. That's what this does, and that's what functions should do by default. The only way to get information into the function is by passing them as these parameters. However, there is another mechanism we can use, and it's the same mechanism I used to implement the recall button. So let me show you how we're going to do this. And this is going to start getting complex, not so much in terms of the amount of code, but the logic behind the code. Let me remove any distractions. I'm going to close this window, and it's going to help to refer to different aspects of this script. So I'm going to split it horizontally so that I can view both the top and bottom. So this is my graph definition, and let's just look at how that is used. So if I come lower down, we've got the main window which invokes my graph, and it passes the Y column name and the X column name. If I want to get this list in, I think what I'd like to do is probably just pass it as an additional argument. So list X. So my graph builder needs three things: what to put on the y-axis, what to put on the x-axis, and the list of columns that are going to be available in the column switcher. So that's all good, and let's just verify that works. I can use the recall button, and now I have my graph with the column switcher set up. The next thing I want to do is the most complex, and that is I want to be able to switch to a different column, and of course I get that for free as part of the script, the column switcher functionality in Graph Builder, but I don't get it for free in terms of these custom buttons I've created. If I click the view histograms now, I want a distribution of oxy and run pulse, but I still get the runtime. So this new selection that's come from the column switcher is not getting transmitted to these buttons, so I need to fix that problem. So when I click on a column here, an event occurs. Now it's actually two events. It's a bit like a mouse click. You press down and you press up, if you like, or the mouse goes down, the mouse comes up. So there's two events associated with a click. And these events I want to interact with, and the way I do that is by making those events explicit. So if I come back to the column switcher I've created, I'm going to give a reference to it, CS, and I'm going to send a message to CS that will allow me to work with those events, or create handlers for the events associated with the clicks. So what message do I send? Well, if I come to the help menu, script and index, the column switcher is an object, and if I come down and look for column switcher, then this object, I can send a message, make column switch handler. Not a very nice name. They give me some example code here. In fact, maybe I'm just going to copy that message, and I'm going to paste that message in here. So make column switch handler. Pre and post are the handlers associated with the down and up events. So let's just double check this. So create a handler for column switches with a callback function which are called before and after the column is switched. So these are called pre and post in here, but these are names of functions that I can provide myself. So I'm going to call it maybe pre CS handler and post CS handler. And those are functions I'm going to have to create. And maybe I will create them now actually. So let's just come to the last function I created was my one way. And then I'm going to create a function called, well, pre-CS. I don't really need both of these handlers. So I'm going to the first one. I'm going to sort of try and say I don't really want to define it. I think I can just do this, and hopefully Jump will allow me to do that. So the one I do want to define is this one. So we use the standard template for a function. But when we define a function ourselves, we can decide what arguments to put into the function definition. In this instance, we don't have control of that. Jump is deciding that for us. And so let's just look at this post. There are 3 arguments that it takes. So I'm going to copy those, and I'm going to put those arguments into here. I'm going to give them shorter names. This is the old column, and this is the new column, and this is the column switcher. I'm just going to call it this. It's this object. It's a reference to the object that we're dealing with. And I just want to double check what these things look like. I'm just going to show them, and then I'm going to run the code, and we'll see what values they take. So to see the values, I can right click and I can show in embedded log. If you split the window, you can't right click on the right hand side, you have to right click on the left hand side, and then you can see show embedded log. Okay, so that's going to show these at the point in time when this event gets triggered. So if I run again, recall, so here's my graph. Now when I click on a column switcher, we should see the output in the log. And there we go. So old column is column runtime. New column is column max pulse. So that's as I was expecting. So the runtime is the old column and the new column is max pulse. One thing I just want to draw your attention to is that this is a column reference. This is the object. Think of a column as a thing in a data table where it's got data in, it's got properties in, it's got a column name. And so runtime is the column name and column runtime is the object. So this is a reference to the object. If I want to get the name from this column reference, I can send a message to it, get name. And the reason I mention that is everything else we've been working with, when I have xcol, this is just the name of a column and this is a list of column names. So for consistency, I want to convert old name into just the string representation. So in here what I can do is to say that xcol name is equal to the new column get name. So that's going to take the value runtime. Oh, so it's the new column, so it's going to take the value max pulse. This is the new name. This is the name that I want to get into. If we come to the very bottom of the script, we have these buttons. So I have a button for the histograms. And this histogram is going to be a histogram of the Y column name. Now that's not changing, but this has changed. So now what I've done is to give a new definition of xcol, which is fine, except that xcol here only exists within this function. All the variables in this function are local to this function. So this definition of the button script doesn't see this change. So how do I get this function communicating with the script that's attached to this button? So here's how I'm going to do it. I'm going to use the same principles that I use for the recall button, and that's to use a namespace. So I'm going to come to the top of my script, and I'm going to do something similar to with the recall, except I don't need such fancy logic. I'm just going to say I have an application namespace, which is always going to be a new namespace, and I'll give it a name. Well, let's call it app.example JSL. So I'm using the same type of pattern as this, and then I put my name to make it totally unique. So that's the new application namespace, and I'm going to use this as a container, and I'm going to put into that container all of the things that I need to persist once this script has finished running. And the things I want to persist are really this information here. So let me come to the very bottom, and I don't know why that comma's there. That's a typo. Let's get rid of that. So I'm going to populate this box, and I'm going to say, well, y column name is equal to y column name. This could be a different name here. This could say something like response. So they don't have to be the same names, but I'm just going to be using the same names here. And app xcol name is going to be xcol name. And let's take the x type. So I can say the app x type. This is the modeling type for the x column. So those are the three pieces of information that I need to persist into runtime, in the sense that, you know, this information is not used until I click this button. And I click the button at some point in the future after I've finished running my script, and after I've clicked, potentially after I've clicked the column switcher. So now what I want to do in this script is say, don't use these variables, but instead use the variables that I put in the box. So now what I want my script to do is make a reference to the box using this line of code. So the first thing the script does is going to create a reference. Now it's no longer a new namespace, it's just a namespace. So it's an existing namespace, and it's been populated with all of this information. So the y column name I'm going to use is the y column name that's in the box, and the x column name is the x column name in the box, and likewise for the x type. So why have I done that? And let's just correct that typo. The reason is I'm going to put a new value in the box for x column name. And where does that new value come? It comes from the column switcher event here. So I want this to be app column name. So I'm putting this value in the box, and it's taken out the box here. So again, I need in my function, if I'm referencing app, I better define it like so. So that's what I mean. It's a complex piece of, not a lot of physical code, but it's a complex piece of logic to get this right. There are more than one ways of solving this problem. I think this is a reasonably elegant way, and more importantly, a robust way of doing it. But let's make sure it works. So we know we get this far. Let's look at, well, first of all, view histograms, make sure this still works. So that's fine, that's runtime. And just to illustrate what we've really done, if I right click on this, I can say set script, and you can see the script. The first thing it does is get a reference to the application namespace. and then it invokes this function based on the contents of that application namespace. And when I click on the column switcher, this value is going to be updated. So let's do this and now click view histograms, and that is working correctly. So that principle works. I can reapply that principle now to the other scripts. So we have at the bottom, the first button was histograms. The second button is either my regression or my one way, and they both need to have this principle applied. So both of those definitions, whether we are here or here, I'm realizing a problem at this stage, but I'm not going to mention it until I finish this. And this is now can be app and app. So let's see, as I'm typing this out, whether you can think of the same problem. So that's the same logic. Now what's going to happen, the column switcher is going to change this, so that makes perfect sense. So let's just run this. Recall. Switch the column and fit the regression line, and the regression line correctly uses max pulse. This would work if all we are doing is redefining the contents of these arguments, but we are changing the logic. In particular, what we need to do is, if the modeling type has changed, I need to change the name of the button. Now I can't do that inside the script, so I have to do it externally. The only place I can feasibly do that logic externally is in the event that changes the column, so in the post handler. So the only place I can put some logic in is here. So I could say this, I could say, well, the X type is equal to new column. Now new column is an object, so I can send a message get modeling type. And now I could ask the question, the same question as I'm asking here, is it continuous? Now maybe for consistency, I'm going to say app there. And here I'm going to say if that value is continuous, then what am I going to do? I'm going to have to redefine, I'm going to have to redefine the name of the button. Else we're going to do this. So based on the modeling type, the button's either going to say perform a regression or perform an analysis of variance. Now again, to reference this name now has to be in the application namespace. And therefore what I'm going to do is say app button 2 is equal to button 2. I can now also reassign the functionality. So if it's perform ANOVA, then we're going to call my one way, and otherwise we're going to call my regression. So let's just think this through, or at least I need to think this through. If it's continuous, then we're going to change the button name to say fit regression line, and the script will, so this actually needs to be the set script. This is the whole of this needs to go in there, not just the definition. So let's just copy the whole of that. So app2 and otherwise we're doing this. So what's going on in my head as I'm doing this, I'm thinking, I'm not sure that I couldn't have come up with a more elegant way of doing this. So this isn't, I think, the prettiest way. So what we often do in code is you have a principle of you write the code to get something to work, and then you can go through a process of refactoring. And the refactoring is you kind of come up with a more elegant design. I'm probably not going to go through the refactoring, but I just want to get this working. It's not the most elegant solution, I think, but I think it still works and it's robust, and that robustness is the important thing. So let's recall. And we've not touched the histograms, so histograms should still work correctly. And we've got a regression line, and that is working correctly. And let's just check the code for the button. So we have the namespace, and then we do the my regression based on the contents of the namespace. To really test this, what I need to do is to put in a list which contains both nominal and continuous variables. So now I have a nominal variable, and I can perform one way. If I switch, I can do linear regression, and if I switch back to nominal, I can do one way. So that is working, and this is robust. There's no ambiguity in what these variables are. We're not making any assumptions about the runtime behavior of jump. We have a namespace, and we are referencing that namespace, and we are repopulating that namespace each time we interact with the column switcher. There's one behavior I spotted. If I click runtime, this goes a bit strange. This alignment we are trying to manage using center alignment on a vlist box, and it looks like for some reason we lose that center alignment. So my two buttons are aligned using this, and that doesn't seem to be working, so I'm going to take that off. So now I'm not trying to center them, so they just appear here. And if I wanted to maybe shift them over to the right a bit more, I could probably, before the center box, I can put, let's think we've got the my graph. So actually this vlist box, these are the two buttons organized vertically, but before I do that, I could maybe put a spacer box in here. Size maybe something like 200 pixels, just to see if this does anything useful or not. And too many arguments, so misspecified. Yeah, so a center box can only contain one thing, so these pieces of content are now going to be organized in a hlist box, and that ensures that the spacer is going to the left of these buttons. And run this again, recall. Okay, so they're shifted over, and like so. So that's probably as good as I'm going to get with that, so that's fine. And you can tweak the positioning if you like by controlling the 200 pixels that I've just put there. So I think we're finished with this script. I'm going to save this as lesson 6, and let me remove the, in fact let me just close that, and I'm going to come back to the home window now, and to test this I'm going to take a totally different data table, and to really see the benefit of the script I'm going to take a table with more columns. I'm going to run my script now, and I'm going to say I've got a response and a huge list of X's. So now I can just very rapidly scroll through this and look to see where there might be strong relationships. So there seems to be a bit of a trend there. I can fit that with the regression line, and I can look at these three groups. I can look at that with one-way analysis of variance. So I've got something which I think is pretty useful in terms of very quickly doing exploration on any data set that we may have. So that wraps up this video, and it, for now at least, and I think this is the last video in the series. I think we have functionality that's given us more than we initially planned, to be honest, and that's maybe why this video has taken a bit longer. This was technically challenging. Scripting the column switcher is probably one of the most complex things you would look to do. Hopefully that's helped you, though. You can see the benefit of doing that. And if you've got any questions on what we've covered in today's video or in any previous video, please put a question in the post below. If you've enjoyed this video, please give it a like, and if you would like to see other related videos, please think about subscribing. All the best, and bye for now.